what is the difference? Means, whether I have discussed it with you or not, I am not sure about it. Can you say what is the difference between science and engineering?
Science, we are studying the theoretical, and engineering, we are implementing that.
No, no. What is the difference between science and engineering? In science, we are implementing many things. See, only one subject in computer science, we are using the term software engineering. Means we are using the terms engineering, that is in software engineering. Okay, in other subjects, we are not using the term engineering. So what is the difference between engineering and science? That is my question.
So engineering is the application of knowledge, and science
No,
is the
science application হয় না সায়েন্সে এত কিছু অ্যাপ্লিকেশন হচ্ছে তাতে নানা রকম ইনভেনশন হচ্ছে Okay, so time is very less. So for that reason, I'm saying that in case of science, when we are doing something, we are not considering the cost factor. Okay, but in engineering, when we are doing anything, we cost is one of the major thing. Okay, so see, when we are talking about software engineering, see, at the last it is written cost effective manner. Okay, so in engineering we have to do everything in a cost effective manner, but in science that cost part is not there, and that is the basic difference between science and engineering. Okay,
Okay.
so engineers know how to implement it in a cost effective manner, so for that reason industry prefers engineers. Okay, they don't prefer scientists, because industry means always there is cost and there is profit and all these things. But in research organization, they prefer scientists, because there is no question of any cost when you are doing research, theoretical research. Okay. So software engineering means engineering discipline concerned with all aspects of development and delivering high quality and useful software in a cost effective manner. Okay. So in software engineering, when we are trying to develop a software, we are the software is going to provide a solution to a problem in the real world. Okay, so software system is provides a solution to a problem which persists in the real world. Okay, and then it consists of two essential components. One is model, abstraction of a part of real world. Algorithm capture the computation involved in manipulating or processing the model. Okay, so what we are doing, this is suppose this is a real world problem. What we are doing, we are taking a abstraction of the real world and we are showing it inside a model, by a model. Okay, and then by means of different types of algorithm, we are trying to solve that problem inside a model. Okay, because our algorithm is not going to change anything in the real world. Whatever it is doing it inside the model. Okay. So two things are very important. One is model, which is abstraction of a part of real world, and algorithm capture the computation involved in manipulating and processing the model. Okay. So to solve any problem, we require a model and we require some algorithms. So is it clear?
Yes, sir.
Now, how to model the real world? That is the next question. Okay, programming language, tools to describe the computer models. Okay, now there may be programming models, computation orientation model, data oriented model, object oriented model. Okay, and this object oriented model, balance view, it shows balance view between data and computation. Okay, and now as we are using object oriented programming language, we are basically concentrating on object oriented model. Okay, other models becomes obsolete. Nowadays we are using object oriented model. Okay. Now, object-oriented information system development involves object-oriented analysis. Okay, so using an object-oriented approach to system analysis. First, we have to analyze the system. Then what we have to do? Object-oriented design, system design. Okay, using an object-oriented approach to system design. And we are having object-oriented programming, using a object-oriented approach to programming. Okay, so if you want to develop something using object-oriented approach, first we have to analyze it, then we have to design it, then after we have to do the programming. So programming will come at the end, not at the very beginning. Okay, but we are only concentrating on programming. We are not concentrating on design, we are not concentrating on analysis. Okay, now if you work in a software project, and for every project in any company, there will be a team. Okay, and there will be only, suppose that project team having 50 members. Okay, among those 50 members, only one or two members is programmer. Others are from other field. They are doing analysis, they are doing designing, all these things they are doing. Okay, programming means programming will come at the end. Okay. So object-oriented development means object-oriented analysis, object-oriented design, then object-oriented programming. All these together forms object-oriented development, not object-oriented programming only. Okay, so far we have concentrated on object-oriented programming only. We are not aware of these two components, object-oriented analysis and object-oriented design. Okay, and object-oriented analysis is a part of software engineering, and object-oriented design is also a part of software engineering. Okay, but as we are discussing object-oriented programming, we should know before doing object-oriented design, object-oriented programming, we have to know how to do this. Okay. So object-oriented design techniques are becoming popular. Inception in early 1980s and nearing maturity, widespread acceptance in industry and academics. Then for doing object-oriented design, Unified Modeling Language, UML, already an ISO standard. for modeling object-oriented system. Okay, so designing means during design, what we are doing? We are doing the model of the real world. Okay, and for modeling, there is a language known as Unified Modeling Language. Okay, it's not a programming language, it's a modeling language. Okay, by which we can do different types of model. And what is model? Which is capturing the behavior of the real world. Okay, see, this is the model. Okay, we can do this model by means of UML, Unified Modeling Language. So what is model? Abstraction of a part of the real world. Okay. So object-oriented analysis and design, Unified Modeling Language, standard object-oriented analysis and design modeling notation. Okay, so there are standard notation of doing modeling. Okay, in UML, and this is defined by Grady Butch, James Rambau, and Eva Jacobson. Okay, so three scientists, mainly these three scientists have developed this. Okay, and it uses model-driven approach, enables creation of graphical models of the system requirements and system design. Okay. Of the system requirements and system design. So, understanding object-oriented development. So, in software engineering, you have already studied, I think, the system development lifecycle, SDLC.
Yes, sir.
Okay, so there are different steps of a project. Okay, so you have to study that in software engineering, or you have probably studied that in software engineering. So there are different phases of development. Okay, first phase is planning, then analysis, then design, then implementation, then support. So different phases are there. Okay, so among these, analysis, design are two main phases. Okay, so we can do this analysis and design by means of UML. Okay, Unified Modeling Language. Okay. So, any question from anybody?
No, sir.
Somebody asking a question. Somebody was asking something. Okay. So, we are doing, we are basically build model, building prototype, doing modeling of a building. You are doing a prototype of a house. Okay. So by means of prototyping, creating a working model of one or more parts of the system for user evaluation and feedback. Okay, so you are modeling one or two parts of a system. You can do the modeling of the whole system, or you can develop it part by part. Okay, and then you can evaluate that model, and then you can get the feedback from that model. Okay, so joint application development, key system stakeholders and decision makers work together to rapidly define system requirements and design. So when you are judging the model, at that time, different stakeholder and decision maker can take part in that, and then you can fix the system requirement, and accordingly you can design. Okay, so initially you are not working on the real thing. You are working on the prototype, then you are designing it, you are taking different types of decisions. Then once the prototype is fixed, then you are going to develop the real thing. Okay. So in my opinion, means try to understand the thing. Suppose you want to build a very big ship. So at the very beginning, you will not start to build the ship. What you will do? You will do different types of designing. You may build a prototype. Then you can test the prototype whether it is working or not. Means prototype means small version of that ship, and then you can test on it. And then if it is working, then only you can build the real thing. Okay, so in software system also, we may work on a prototype, small prototype. Then if the prototype is working, then we go for the, okay. So other requirements are project management, interviewing, data collection, user interface design, testing, conversion techniques. So a lot of other things are there in object-oriented development. Okay. So there are different concepts of object-oriented programming. You know already. See, object, attributes, object identity, method, instance, message, class, encapsulation, persistence, information hiding, polymorphism, generalization, specialization, subclass, multiplicity, inheritance, superclass, association relationship. Lot of things are there. Okay, so lot of concepts are there. Okay, so you have to know all these concepts. You have to clear idea about all these concepts to develop something using object-oriented methodologies. Okay, so object-oriented design.
Are you changing the slide because the slide is freeze for us?
Any question?
Yes, sir. The slides are freeze, not changing.
The slide, yes.
Okay, sir. Now it's changing.
Not audible properly. Repeat.
Actually, the slide are not changing. That's why you can. Slide are not changing.
Slide?
Slide are not visible.
Slide is not changing.
Now it's what?
Slides are not visible properly. Okay. Now it's okay.
Yes.
Now it is okay.
Yes, sir. Now it's
Okay.
okay.
1 minute. So object-oriented design, the objectives of object-oriented design to explain how a software design may be represented as a set of interacting objects that manages their own state and operations. Okay. So object-oriented design means there must be some objects. Okay. And objects will interact with each other. And by interacting objects, how you can achieve a software design, a full-fledged software. Okay, and that is one of the objectives of object-oriented design. Okay, to describe the activities in the object-oriented design process. Okay, what are the activities in object-oriented design process? To introduce various models that can be used to describe an object-oriented design. So as I have already told, there are models. Okay, so we have to introduce those models to describe different types of object-oriented design. Now show how UML may be used to represent this model. Okay, how used or may be used to represent these models. What I have told, UML is a unified modeling language. Okay, so by means of UML, we can draw different types of models, and by means of unified modeling language, we can describe or represent different models. Okay, so approach focuses on improving the maintainability and reusability of software system through a set of techniques, notations, tools, and criteria. Okay, so the approach is to focus on maintainability. Okay, how we can maintain the software and how we can reuse the software for development of another software of same kind. Okay, so that is our focus area in object-oriented development. Okay, so activities are conceptualization, object-oriented analysis and modeling, object-oriented design, then implementation, then maintenance. Okay, so these are these things we have to do. But in this chapter, we will basically concentrating on object-oriented analysis and modeling and object-oriented design. Okay, then object-oriented the implementation part means programming part. Okay, so here we will concentrating on these two. So conceptualization is the first thing to establish the vision and core requirement of the software system to be developed. What we have to do? Suppose we have to develop a software system or software program. Okay, so before doing that, we have to conceptualize the thing, what we have to do. Okay, that is the vision and core requirement, not detailed requirement. What we have to do, simple. So that is known as conceptualizing the thing. Okay, then object-oriented analysis and modeling to build models of the system described the desired behavior using the notation such as unified modeling language. Okay, so we have to build the model for system desired behavior. Okay, so when we are building a model of a ship, that small replica of the ship will behave like the real ship. So similarly, when we are modeling a software system, the model will behave like a actual software, but it is not the actual software. Okay, so to capture the essential relevant aspect of the real world and to define services to be provided and or the problems to be solved. Okay, so what type of service it will provide, what type of problem it will solve, that will be shown in the model. To simplify reality, to better understand the system to be developed. Okay, now to simplify reality. See, when we are building the model of a ship, we are not adding the all complexities of the ship. Okay, we are simplifying the thing and we are modeling only the main aspect. Okay, to better understand the system to be developed. Okay, then next comes object-oriented design. To create an architecture for implementation, how we will implement it, represent in terms of objects and classes and the relationship among them. Okay, so in object-oriented development, there will be some objects, and objects are instance of classes. So we have to think about objects and classes and how they will relate with each other. Then comes implementation, to implement the design by using the object-oriented programming language, that is Java. You can implement it by means of Java, you can implement it by means of Python. Okay, a lot of object-oriented programming languages are available now, but Java and Python are most popular right nowadays. Okay, then after that, after development of all that, we will implement it. Okay, then after sometimes, due to the changing environment, we have to change something in the software. Okay, and that comes under maintenance. Okay, suppose we have developed the software for say Windows 2000. Now, after that, Windows XP came. So what we have to do, we have to develop that software. We have to change the software which is suitable for making it suitable for Windows XP. That comes under maintenance. But nowadays, in software industries, 80% people are working on maintenance because that is the main thing right now. Okay, because we have to the software suitable with means the changing environment. A lot of people are working on maintenance project. Okay, almost 80%, I think. Okay, so these are different steps of object-oriented designs. These detailed activities are these. See, activities are these, object-oriented development. Okay. So, any question up to this?
No, sir.
Any question from anybody? Okay. So, what are the advantages of object-oriented development? First thing is easier maintenance. Okay. So, objects may be understood as a standalone activities. Okay. So, maintenance of that software will become easier because the objects are standalone entities, which may we can means when we are concentrating on a particular object, we don't have to think about other object. If we keep the interface same, we can work with that object only, or we can work with that class only. If we keep the interface same. Okay, so that makes maintenance easier. Okay. Now, if you develop an object, we can reuse that object later. Okay, so and that makes the system development cost effective. So what I have told, in software engineering or in any engineering, cost is the major thing. Okay, if it don't involve cost, then that is not engineering. That may be science, that may not be engineering. So when you are doing engineering, you have to take care of cost. Okay, so if you make a system reusable, then the cost of development of later project becomes very less. Okay, because you can reuse many components. Okay, now for some systems there may be an obvious mapping from the real world entities to system objects. Okay, so real world entities can be easily mapped into a system object. Okay, so sometimes it is quite easy to do that. Okay, now what are the methodologies? Okay, so before development of this UML, a lot of scientists develop different types of methodologies. Rambau developed, then Buch methodology, then Jacobson methodology. Okay, so these three scientists proposed their own methodology of object-oriented development. Buch, Rambau, Jacobson. Okay, these are known as Buch methodology, Jacobson methodology, Rambau methodology. Okay. So, see, you can read this because these are all sort of history that you can read all this, because I'm not going to read out this because it's due to the time constraint. Okay. So, you can read this later. Okay, 4 phases are there. Then analysis is there. Okay, then three different parts of OMT modeling: object model, dynamic model, functional model. Okay, then object model, object diagram. Okay, OMT dynamic model, OMT functional model, data flow diagram. Okay, so see, probably you are aware of flowchart in programming language. First year you have studied flowchart. Yes or no?
Yes, sir.
Yes, sir.
Okay. Okay, so this flow chart is not part of UML. Okay, but earlier it was there. Okay, now when we are drawing flow charts, we are using some notations. We are using some symbols. Okay, now see, these are symbols. So if you draw a ellipse that represent process in the data flow diagram. Okay, process means any function being performed. Then arrow. Arrow means data flow, direction of data element movement. So from this to this, from this direction to this direction. Then two line, data store, location where data is stored. Okay, and this rectangle, external entity, source or destinations of data element. Okay, so when you are drawing any flow chart or any flow diagram, you have to use these notations. And these notations is acceptable worldwide. If you use other notations, then that is not acceptable. Okay, all people will not understand. Okay, so these notations are proposed by Rambau, and that is accepted by everybody. Okay. Then system design is there. Okay, object design is there. Then implementation is there. Then Booch methodology. Okay. And diagrams proposed by Booch is class diagram, object diagram, state transition diagram, module diagram, process diagram, interaction diagram. Okay, so these diagrams are proposed by Booch. Okay, Jacobson methodology. He proposed use case diagram, he proposed object-oriented software engineering, and he proposed object-oriented business engineering. Okay. Now, use case diagram is proposed by Booch. So, sorry, Jacobson. So, I will discuss use case diagram in detail in UML. Okay. Then object-oriented software engineering. Objective is build model, use case model, domain object model, analysis object model, implementation model, test model. Okay, so these are under object-oriented software engineering. Then object-oriented business engineering, under object-oriented business engineering, analysis phase, design and implementation phase, testing phase, unit testing, integration testing, and system testing. Okay. So all these things are basically done before the UML. Okay. So see here, I have described only 3 scientists. Means I have described the work of only 3 scientists: Booch, Rambau, and Jacobson. They have proposed all these things. Okay. So all over the world, different peoples have taken different methodology, and different companies have taken different methodologies to do object-oriented development. So now the problem is that when they are trying to communicate with each other, the communication is not successful because the notation used by one company that is different from another company. So that becomes, means one company is saying that I am following the Jacobson method, another company is saying I am following the Booch method. Okay, now when they are communicating, trying to communicate, means they are not, means one company is not habituated with the notation used by other company. Okay, or methodology used by other company. Okay, so then that becomes a problem. So everybody understood the need of a standardized thing of object-oriented development. And from that, this UML developed, Unified Modeling Language. Unified means there are a lot of modeling language before UML. So they have taken the best from existing methodology, and that by that they formed a modeling language, okay, which is acceptable to all. So mainly these UML have taken the features, taken the thing from Booch, Rambau, and Jacobson. So for that reason, I have told all these things. Okay, who have proposed what? So uniform modeling language is a modeling language, not a system design or development methodology. It is not a development methodology or it's not a system design. So those things are, means in software engineering you have studied a lot of things. Okay. Now it is used to document object-oriented analysis and design. Okay, by that we are doing object-oriented analysis and design. Okay. Now it is independent of any specific design methodology. It's not dependent upon any design methodology. It is independent of any design methodology, any specific design methodology. Okay. Now wait.
हेलो आदित्य कैसे
आवाज नहीं आ रहा यार सच में। ओके बस चल गया पता नहीं लीव हो गया क्लास का नहीं यार
राहुल
स्लाइड चेंज हो रहा है तुम्हारा।
हाँ
So listen. So the origin is in late 1980s and early 1990s, different software development houses were using different notations. What I have told earlier, that different software development houses, different companies were using different notations. Okay. So UML developed in early 1990s to standardize the large number of object-oriented modeling notations. Okay. So to take what I have told earlier, that this UML take different object-oriented modeling notation to standardize the whole thing. Okay. This is done in early 1990s. Okay. So it's based principally on OMT proposed by Rambau, 1991, Buch methodology, 1991, object-oriented AC, Jacobson, software engineering, Jacobson, 1992, Odil's methodology, 1992, Slayer and Miller methodology, 1992. Okay. See this one. Okay, so this, if you consider this is UML. Okay, so UML, within UML, we are having OMT, then Buch methodology, then object-oriented system engineering, software engineering. Okay, so UML have taken some part of OMT, this part, but this part is not taken. Okay, some part of Booch methodology, this part, but some part are not taken. Software engineering, some part is taken, and some are added. Okay, and it has also taken some part of these two, that is Odell's methodology and Slayer methodology, but that is not shown in this figure. But normally means basically most means UML have taken most of its notation from these three. Okay, and I have also told the book written by Butch Rambaugh Jacobson, okay, to study UML. And these are three main scientists who have developed this UML. Okay, and UML developed from the work, basic work done by these three scientists. Okay, and after that, some part are also added into the UML. Okay, this part. These parts are not part of OMT or OAC or Booch methodology. Okay. So UML as a standard. What I have told earlier, UML is now a ISO standard. Okay. So it is adopted by Object Management Group, OMG, in 1997. Okay. And what is OMG? OMG is an association of industries. Okay, so if any language is not accepted by industry, then that becomes useless. So this UML was first accepted by OMG, okay, Object Management Group, and that is an association of industry, promotes consensus notations and techniques, use outside software development. Nowadays we are using this UML in outside software development, outside software engineering or software organization. In car manufacturing also we are using UML nowadays. Okay, in lot of fields we are now using UML. Although it was first developed for software development, but nowadays we are using it in many areas, many domains. Okay, so UML definition by OMG. Unified Modeling Language is a graphical language for visualizing, specifying, constructing, and documenting the artifact of software-intensive system. Okay, that is the definition proposed by OMG. Okay, so if somebody asks that what do you mean by UML? Okay, if you write this definition, then nobody can deny you or nobody can tell that this is wrong. Okay, so you have to memorize this definition. So every word has a meaning. The Unified Model Language is a graphical language. It is not a text language. Okay, so we are aware of Java, we are aware of C++, we are aware of C. All these are programming language, and we have to write different types of text for that, command for that. But it's a graphical language. It's not text. UML is a graphical language. And what is the use of this? For visualizing, specifying, constructing, and documenting the artifacts of software-intensive system, which constitute the software-intensive system. These artifacts can be visualized, specified, constructing, and documenting. These can be done by means of UML. Okay, the UML offers a standard way to write system blueprints, including conceptual things such as business processes and system functions, as well as concrete things such as programming language statements, database schemas, and reusable software components. Okay. So it can do different types of conceptual things. Okay. are UML models are required. Okay, so a model is required to capture only the important aspect. Okay, so you are aware of model. Okay, you are aware of a model of a car. You are aware of a model of a aeroplane. You are aware of a model of a ship. So think about those models. Those models can capture only the important aspect. Okay, it is not going to capture all intricate details about the real thing. It is only capturing the important object, important aspect. Okay, and UML is a graphical modeling tool. Okay, so it's a graphical modeling by means of graph, means different types of images, okay, or different types of symbols. It can model the real world thing. Okay, and it is easy to understand and construct, helps in managing complexity. So what I have told, what is the challenges of software development? First word is the complexity of the system. So by means of UML, we can manage complex. It can manage complexity. UML can manage complexity. Okay. Now, what I have told, UML is a graphical modeling tool. So obviously there will be different types of diagrams. Okay. So there are 9 diagrams used to capture different views of a system. Okay. So 9 diagrams are there. Okay, all about the systems, and there may be different views of a system. Okay, and provides different perspective of a software system. Okay, and it provides different perspectives of a software system from different perspective of the software. These diagrams are useful. Okay, diagrams can be refined to get actual implementation of a system. Okay, so initially it will capture only the important aspect. Later we can refine this diagram to get the actual implementation, means get the actual software. Okay, so initially we will start with a very simple diagram, then we will make it, we will refine it to add intricate details to that diagram. Okay, so here, see one thing I have written, 9 diagrams are used to capture different views of a system. Okay, so there are different views of a single system. Means we can see a system from different viewpoint. Okay, and for showing different viewpoints, there are altogether 9 diagrams. Okay, now there are different types of views. Okay, what are those? First is user views, then structural view, behavioral view, implementation view, environmental view. Okay, so these are 5 views. Okay, so UML model views, these are 5 views, and there are 9 diagrams. Okay, this is a very common question in any interview board. How many diagrams are there in UML? 9 diagrams. How many views are there? 5 views. Okay, so is it clear? See this one. See, there are 5 views. Okay, and there are altogether 9 diagrams. See, 5 views: user view, structural view, behavioral view, environmental view, implementation view. Okay, and there are 9 diagrams: class diagram, object diagram, sequence. Yes.
আপনার যে স্লাইডটা ওটা না আটকে গেছে, আর মানে একটা অবজেক্ট ওরিয়েন্টেড ডিজাইন এন্ড অবজেক্টিভ ওটাতে আটকে আছে স্যার, আর মুভ করছে না।
এখন
No, sir.
এবার কোন ডায়াগ্রাম দেখতে পাচ্ছ?
না স্যার।
হ্যাঁ স্যার, পাচ্ছি।
হ্যাঁ স্যার, এবার দেখা যাচ্ছে।
এই UML ডায়াগ্রামস হেডিং আছে, সেটা পাচ্ছ তো?
হ্যাঁ স্যার।
হ্যাঁ স্যার।
Okay, so what I have told earlier that in UML there are 9 diagrams and 5 views. So in this diagram, see user views, structural view, behavioral view, implementation view, environmental view, and 9 diagrams are there: class diagram, object diagram, sequence diagram, collaboration diagram, state chart diagram, activity diagram, component diagram, deployment diagram. So 9 diagrams are there. Okay, now what I will do after this means in the next class I will discuss different views. Okay, and I will discuss these diagrams. Okay, how to draw these diagrams. Okay, now see, are you able to see user's view here in the slide?
Only the diagram is there.
It's taking some time.
Yes, sir. Now user view is there.
Yes, it's taking time. So user view, there are, what I have told, there are 5 views. So I will discuss each and every view right now in broad. Okay, so what user view is doing, how user is seeing the software, that is the user view. Okay, so user view means define the functionalities or facilities made available by the system to the user. Okay, so how you are seeing a software means what software means the facility the software is providing to us, that is the user view, that is the software to me. Okay, and that is the user view. Okay, so user view captures external user views. Users are external to the software. Okay, user don't know what is happening inside the software. From the outside of the software, user is seeing the software from its functionality. Okay, and it don't have any idea what is happening inside the software. So it's a black box view of the system. And internal structure, the dynamic behavior of different system components, the implementations are not visible to the user. Okay, and it is considered as central view. Okay, and that is the main thing, means what the software will do, and that is the main thing for any software. So it is a central view of the software. Okay, so is it clear? User view.
Yes, sir.
Then structural view. Okay, now what is structural view? Means from the name you can understand it is about the structure of the software. Okay, so what is the structure of the software? So in object-oriented design, object is the main thing. So within the structure there must be object or classes. Okay, so define the kinds of object or classes important to the understanding of a system and to its implementation. Okay, It defines the kinds of objects or classes to important understanding of a system and to its implementation. Okay, so what are the objects or classes will be there inside the software and how you will, those will interact with each other. Okay, captures the relationship among classes. So how classes are related with each other, and it is a static model, not changes with time. So the classes in any software program will not change with time. Okay, these are static. Means, see, if you write any program and you suppose inside the program, if you define say 10 classes, okay, those classes will not change with time. Those classes will be permanent inside the program. So this is a static model. It is not changing with time. Okay. Then behavioral view captures how objects interact with each other to realize the system behavior. How we are getting the output of the software. How objects are interacting with each other to give that output. Okay, and as objects are interacting with each other in different manner, and that changes with time, and that changes with the changes in the external environment, this model is a dynamic model and it changes with time. So behavioral view is showing that. Okay. Then implementation view captures the important component of the systems and their dependencies. How to implement that? How to implement that in a hardware? Okay, that will be shown by this implementation view. Okay, then environmental view shows how different components are implemented on different pieces of hardware. Okay, so what will be the hardware? That is the first question, and then what component will be stored in which hardware? Okay, how it can be implemented in different hardware. That is environmental view. So these UML diagrams I have shown earlier. Okay. Then next question is, are all views required for developing a typical system? That is the next question. Okay, the answer is no. Okay, all views are not required for a typical system. Okay, for different types of system, different views are useful. Okay, so the answer is no. Use case diagram, class diagram, and one of the interaction diagram for simple system. Okay, so use case diagram, class diagram, and one of the interaction diagram. Sorry, implementation diagram. Okay, so we require use case diagram, we require class diagram, and we require any of these diagram. Okay, for simple system. Then state chart diagram required for developed to be developed when a class state changes. Okay, so state chart diagram is required when the state of the system is changing with time. Okay, but when the states becomes 1 or 2, it becomes trivial. In that case, it is not required, it becomes trivial, so it is not required. Deployment diagram is in the case of large number of hardware components are developed into the system, are required, used in the system. So in that case, we have to draw the deployment diagram. Okay. So normally we require class diagram, use case diagram, component diagram, sometimes implementation diagram, and when lot of hardware is there, then we require development diagram, otherwise it is not required. we require state chart diagram when the state of the object is changing very frequently, and there are a lot of states of the object. In that case, we require state chart diagram. If there are one or two states only, then it is not required. It becomes trivial. Okay, so normally we have to study use case diagram, class diagram, and object diagram. Class diagram and object diagram are very similar, and we require sequence diagram, collaboration diagram. Okay, and sometimes we require state chart diagram when states are changing. Okay, and then rarely we require development diagram, deployment diagram. Okay. So, if you have any question, you can ask. Any question? See, I'll try to complete the syllabus by consuming less time. Okay, so for that reason, I am making the slides as small as possible, and I am discussing only the main thing. I'm not discussing all. So if you have any question, you can ask. I know you are having mid-semester exam, so for that reason, I am making it short. As short means whatever possible. No question from anybody? In that case, I will close the class. Okay, then I'm closing this one.